Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for searching an element in a rotated sorted array. Let's look at the problem description. We are given an integer array nums which is sorted in ascending order with the distinct values. There are no duplicates in the sorted array. Okay, and also that sorted array may be rotated at some random pivot index. So with that input array and the target integer value, we have to return the index of the target value in that rotated array. If the target value is not present, we have to return -1. Also, we need to write this algorithm with order of log n runtime complexity. Let's take a look at the example 1. So the nums array has 7 elements: 4, 5, 6, 7, 0, 1, 2. The target value is 0. And the 0 is located at index 4. So the output is 4. In the case of example 2, the same input array but the target value is 3, which is not present in the nums array. So the output is -1. And in the case of example 3, the input array has only one element and the target value is 0, and that is also not present in the array. So we have to return -1. The constraints for this problem are: the length of the array is ranging from 1 to 5000, and the individual elements value is ranging from -10,000 to 10,000, and all the elements in the array are unique. There are no duplicates. Okay, and also that array is ascending array, that is possibly rotated, and the target value also is ranging from -10,000 to 10,000. Let's look at the approach to solve this problem. We are given the input array nums with 7 elements and the target value is 0. The 0 is located at index 4, so the output is 4. Okay, the brute force approach is we can sequentially traverse the nums array and then return the index of the element which is matching as an output. Otherwise, finally we can return -1. But that approach leads to a order of n time complexity, but we are expected to solve this problem with log n time complexity. Okay, we can use the binary search technique to achieve that goal. For example, in this case the array has 7 elements. Okay, we can do the basic binary search with little bit of additional checks. If the array is not rotated, we can simply check the target value with the mid elements value and then choose the sub array in which we can continue the search. But in this case the array is rotated. Okay, even though it is sorted, it is right shifted 4 times. Okay, so in this case, in addition to comparing the target value with the mid element, we have to compare the target value with the boundary elements of the current sub array. For example, let's begin with the original array which has 7 elements. So the start and end indexes are 0 and 6 respectively. So first time we compute the mid elements index, which is 3, that points to 7. Okay, if the target value is less than the mid element, then we can choose the left half, but the left half may contain the rotated value. Even though it is sorted, it may not contain the value 0. If you look here, the 0 is present at the right half of the array. Okay, so to pinpoint the location of element which contains the target value, we need to check the boundary elements against the target value to make sure that subarray possibly has the target element. For example, in this case the target value is 0, the mid element is 7. So because the target value is less than 7, we can assume the value probably in the left half of the array. But in addition to checking with the mid element, we also have to check with the boundary element. In this case, the left boundary is pointed by the start pointer. So we have to compare with the start element. If this is also less than the target value, then for sure we can choose the subarray starting from the current start index and mid minus 1. If it is not, then we have to skip that boundary element and then proceed the search between this element and this element. Basically we skip the first element. Similarly, in case if the target value is greater than the mid element, we need to make sure the right boundary element, which is pointed by the end pointer, also greater than the target value. In that case, we can confidently choose the right subarray for the further search. We repeat this until the start and the end pointer cross each other, or the mid element which has the target value. If the mid element has the target value, we return that mid index as the output. Otherwise, after the search is completed, then finally we can return -1, saying that that element doesn't exist in the array. Okay, so that's what I have written here. Basically, we can solve this problem using the binary search. And first we initialize the start and end and mid indexes. Then we traverse the nums array until the start and end indexes cross each other. Okay, each iteration we compute the mid index, and then we compare the target value with the mid element's value. If the target value is less than the mid element's value, then we check the target value with the left boundary, which is pointed by the start index. If the target value is greater than the start element, then we can update the end pointer with mid -1. Basically, we are choosing the first half of the current array. Otherwise, we skip the start element, so we increment the start index. Next, if the target element is greater than the mid element, then we again compare the target value with the right boundary element, which is pointed by the end index. Okay, if the target value is less than the end element, then we can update the start pointer with mid +1 to choose the second half of the array for the further search. Otherwise, we decrement the end index, so we can skip the last element. Okay, otherwise, if the target value is equal to the element at mid index, then we can return the mid index as the output. At the end of this binary search, if the mid element doesn't have the target value, then finally we return the -1 as the output for the failure case. Let's look at the flowchart. Input for this procedure is a sorted nums array and the target value. First we initialize the start, end and mid indexes. Start with value 0, the first element's index, end with the length of the array -1, the last element index, and the mid will be initialized with -1. Okay. Then we enter this for loop. Each iteration we compute the mid index, and then we compare the mid element's value with the target. If the target value is less than the mid element, then we check whether the left boundary element, which is pointed by the start index, is also less than the target value. In that case, we choose the left half of the array by setting the end pointer for the next search with mid -1. Otherwise, we skip the first element by incrementing the start index. Okay. If the target value is greater than the middle element, then we check whether the right boundary element is greater than the target value. If that is true, then we choose the first half of the array for the next search by setting the start pointer with mid +1. Otherwise, we skip the last element by decrementing the end pointer. We repeat this until the start and end pointer cross each other. Okay. And if the target value is equal to the mid element's value, then we return the mid index as the output. Let's move on to coding. First I initialize the start index with value 0 and then the end index with the value length of the input array minus 1 and then the mid index with value minus 1. Next I write the for loop and this will run until the start and end pointer cross each other. Each iteration I compute the mid index by adding start plus n minus start divided by 2 and then I compare the target value with the element pointed by the mid index. There are three cases. If the target value is less than the mid element's value and if the target value is greater than the mid element, the third case is the target value is equal to the mid element. Okay. So if the target value is greater than the mid element, then I again compare the target value with the left boundary element pointed by the start index. If that is also less than or equal to the target value, then I choose the first half of the array by updating the end pointer with mid minus 1. Otherwise, I skip the start element by incrementing the start index. So in the case of target value is greater than the mid element, again I check with the right boundary element. If the right boundary element is greater than or equal to the target value, then I update the start pointer with mid plus 1. So I choose the second half of the sub input array. Otherwise, I skip the last element by decrementing the end pointer. If the target value matches the mid element's value, then I return the mid index. Otherwise, at the end, I return minus 1 as the output for the failure case. Next, I'm going to run the test cases. Compilation error. Okay, I have to remove this. Let me rerun the test case. All the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next, I'm going to do the code walkthrough with sample input. The given nums array has 7 elements 4, 5, 6, 7, 0, 1, 2 and the target value is 0 which is located at index 4. So the expected output is 4. Okay. First we initialize the start index and end index and mid indexes. So in this case the start is initialized with 0 and end is initialized with 6 and mid is initialized with minus 1. Then we enter this for loop and here we compute the mid index by adding start plus n minus start by 2 which gives 3. Okay, so this is the mid element. Okay, then we compare the target value with the mid element and the target value is less than the mid. So we enter this condition. Here we check the left boundary element is also less than the target value, but in this case that condition fails because 4 is greater than 0. So we simply skip the first element by incrementing the start index. So the start index is changed from 0 to 1 and the end index remains 6 and in the next iteration again we compute the mid index. Here also it is 3. 1 plus 6 minus 1 divided by 2 will be 3. Okay, so again it is pointing to the element 7. So again we check whether the target value is less than the mid element. Yes, it is true. And then we check whether the boundary element, the left boundary element pointed by the start index is also less than target value. In this case it is 5 which is greater than the target value. So again we increment the start index and skip this element in the next search. So start index is incremented, so it is changed from 1 to 2. So in the third iteration, the start index is 2 and the end index is 6. So when we compute the mid index, it is 2 plus 6 minus 2 divided by 2, which is 4. So the mid index is 4, that is pointing the element which 0. Okay. And we compare the target value with the mid element's value. We check whether the target value is less than the mid element, it is not, and if it is greater than the mid element, it is also not, but it is equal to the mid element, so we return the mid, which is 4, as the output, and that 4 is an expected output. Next, I am going to do the time and space complexity analysis for this solution. Time complexity of this procedure is order of log n. In the case 1, the nums array has 7 elements. Okay, as per the previous code walkthrough, this for loop performs 3 iterations, which is approximately log 7. So if there are n elements, this for loop performs log n number of iterations. So the time complexity for this solution is order of log n. Space complexity is order of 1 because we are not allocating any additional space in terms of input size. Instead, we use only 3 variables. So that's why the space complexity is order of 1. Thanks for watching this video. Have a great day.